Hello, welcome to My Easy Statistics. Please like, share and subscribe the channel. Contact me for data analysis and training. You can contact me through email or WhatsApp. Part 3, Covariance and Estimation Calculation. In this video, we are going to discuss about covariance and regression estimation calculations. First, we are going to discuss using SPSS software how to do regression analysis, and I'll show you the same analysis how to do in SPSS Amos. Okay, so we'll see the comparative results first in SPSS, and we will see the same type of analysis in SPSS Amos and compare the relationship between both softwares. Okay, before that we will discuss about regression analysis, basic fundamentals of regression analysis. In regression analysis, we have simple linear regression. In simple linear regression, we have one dependent variable and one independent variable. If we have one dependent variable and one independent variable, the equation will be y is equal to a plus bx. Okay, plus error. I'll explain you what is this error. But the formula is y is equal to a plus bx, where y is a dependent variable and x is independent variable. A is the intercept and b is a coefficient of x. If we have more than one independent variable, imagine we have two independent variables, they are x1 and x2, then the equation will become y is equal to a plus b1 x1 plus b2 x2 plus error. Error means unexplained value of y is called as error. So we always keep as error. So for multiple linear regression, in this case we have two independent variables, then the equation is becoming y is equal to a plus b1 x1 plus b2 x2 plus error, where a is intercept, b1 is a coefficient of x1, b2 is a coefficient of x2. We will take one example where we have two independent variables, experience and education, impacting the sales. Sales is a dependent variable. Then our equation will become sales is equal to a plus b1 experience plus b2 education plus error. I already said experience and education, these two are independent variables and sales is a dependent variable. Okay, what is this error? Error means, see, the amount of sales performed by an employee is not only explained by experience and education. There may be some other parameter also which explains how much amount of sales the employee is doing for a quarter, right? So here we are trying to understand what is the impact of experience and education on sales, right? But sales is not only explained, amount of sales performed by the employee is not only explained by experience and education. There may be other parameter, unexplained parameter. That unexplained parameter is treated as an error. So always remember, in the equation we will have errors also. What is error? The unexplained parameter. So sales, amount of sales performed by employer is equal to a plus b1 experience plus b2 education plus error. We are saying error is a term or a parameter which is not being considered in this case or in this analysis. So here always error is unexplained one. So I want to just say once again, experience and education, we are trying to understand the impact of experience and education on sales, right? Do we think only experience and education will impact sales? No, there may be some other parameters also. So that unexplained parameter is called as error. So the equation will become sales is equal to a plus b1 experience plus b2 education plus error. So always we keep error. Now what we will do is we will take SPSS example. First we will do analysis in SPSS. Then the same case we will take into Amos and we will discuss in the Amos also. Now this is the SPSS example where we have sales. This is the amount of sales performed by the employee in a quarter. And this is example of experience and education. Experience is number of years of experience the employee is having. Education is number of formal years of education the employee has. So we are trying to understand what is the impact of experience and education on sales. So let's start the analysis. Analyze, regression. In regression, we are doing linear regression. Because the dependent variable is a scale data, we are doing linear regression. In this, we'll take sales as dependent variable, experience and education as independent variable. Now let me click OK. Once I click OK, now we are in the output screen. In this, we will discuss the main important points. In this, the first thing we will see is model summary. In this model summary, we can see R square value. This R square value is 0.976. What is R square value means? It is a variance explained by the independent variables on the dependent variable. Means how much variance of the dependent variable was explained by the independent variable, means around 0.976. If you want to say in percentage, it is 97.6% of variance is explained by the independent variables on the dependent variable. Means they are explained very adequately. We got very good R square value. This R square value generally in statistics we want it to be more than 0.7. If it is more than 0.7, it is called as adequate. It is good. Now here we got it 0.976. 97.6 variance of the dependent variable is explained by the independent variable. Now we will see directly the impact study. How much impact these independent variables are doing on the dependent variables. That we can understand with the help of this coefficients table. Now you can see here experience and education. Experience, first we must see the significant value, whether it is significantly impacting or not significantly impacting. See the significant value. The value what we got for experience is 0.000. If the significant value is less than 0.05, it is significantly impacting. That is, experience is significantly impacting the sales, right? And education. If this education value, the significant value is less than 0.05, 0.05 means if we treat the confidence interval as 95%, the significant level will be 5%. 5% is nothing but 0.05. If the p value, that is significant value, is less than 0.05, we say the independent variable is having significant impact on the dependent variable. In this case, education is also significantly impacting the sales. So both experience and education, these two are significantly impacting the sales. Okay. In null hypothesis wise, if you want to say, you must keep a null hypothesis stating that experience has no significant impact on sales. Okay. P value is less than 0.05. If p value is less than 0.05, reject the null hypothesis. So in this case, significant value is how much? 0.000, which is less than 0.05. So we are rejecting the null hypothesis. The conclusion is experience is significantly impacting sales. In the same way, coming for education, null hypothesis should be stated. Education has no significant impact on sales. If p value is less than 0.05, then we reject the null hypothesis. If we reject the null hypothesis, the conclusion is education is having significant impact on sales. So these are the two conclusions which have come. Education and experience both are significantly impacting sales. Now let us come to the important points of understanding how much impact they are doing. Now for that purpose, we must see unstandardized coefficients. Unstandardized coefficients, if you see, experience is how much? 1874.5. Okay, so how to interpret this? Means if 1 unit increase in experience, the sales will increase by 1874.5 units. Next, coming to education is having impact of 609.391. It means if 1 unit of education is increasing, then sales will increase by 609.391 units. Here you can understand this, we are saying in unit wise, 1 unit increase in education. And how many units of increase in sales we are saying? 1 unit of education is increasing, 609.391 units of sales are increasing. Now you must understand, education, experience, sales, these are in different units. Even at this in this case, experience is measured in years of experience. Sales is measured in how many dollars of sales the employee is doing per quarter. This is per quarter we are saying, right? So here we can understand experience is having more impact than education, right? So this is unstandardized coefficients. If you want to write in terms of an equation, sales is equal to, what is the intercept in this case? Minus 10,385.338. This is the value. So this is A value. We already said in that A value, intercept value is 10,000 minus 10,385.338. And this is also significant value. What is B1 value? B1 means for experience it is 1874.5. For education it is 609.391. This is unstandardized value. But when you want to compare which is impacting more and which is impacting less, we must not say unstandardized value, but we must see standardized coefficient values. We must see the standardized coefficient value. What is the meaning of standardized coefficient value? Means when you want to compare them, which is impacting more, then you must have a standardization. Of course, in this case, experience, education, both are measured in terms of years of experience only. Units are years only. But in real-time situations, we'll have different type of independent variables. I'm saying, for example, let me give an example. We want to see the impact of attendance, impact of IQ, okay, impact of students' hours of preparation on marks. Marks is the dependent variable. And we are saying 3 independent variables. This is a separate example I'm saying. In this case, independent variables, IQ is one independent variable. Okay, hours of study is one independent variable, attendance is another independent variable. When you want to see these 3 different independent variables impact on marks, we cannot say which is high, which is low, because these independent variables are in different scales. So when you want to compare, what you must do is you must make a standardization of the value. After standardization only, we can say which is impacting more, which is impacting less. So for that purpose, we will use standardized coefficient value. Please understand carefully. Standardization coefficient value is used for comparing between the independent variables, which is impacting more and which is impacting less. Now if you see standardized coefficient values for experience and education, for experience it is 0.919. For education it is 0.244. So easily you understand that experience is impacting more than education. So I want to just clearly say once again, unstandardized coefficient is used for the equation purpose, to understand how much impact is made by the independent variable on the dependent variable. For example, you can see if experience increased by 1 unit, the sales is increasing by 1874.5 units. This is the unit which you are using for unstandardized coefficients, right? For education also we said, if 1 unit of education is increasing, the sales is increasing by 609.391 units. So this is for unstandardized coefficients. But when you want to compare between experience and education, then you must see standardized coefficient value. So it's always better to report unstandardized coefficients when you want to study the impact of independent variables on the dependent variable. And when you want to compare between the independent variables, you must see standardized coefficient values only. So I think I am clear in explaining what is unstandardized coefficients and what are standardized coefficients, and when we must use unstandardized coefficients and when we must use standardized coefficients. Right? In this SPSS analysis, what we did, we have discussed first what is R square. R square is a variance explained by the two independent variables on the dependent variable. It must be more than 0.7. In this case, it is 0.976. And we have discussed the coefficients. How much is a significant impact of experience and education. Now what we will do, we will take the same example and we will do in SPSS Amos, and let us see the values in Amos. Right. This is an example which we are doing in SPSS Amos. This example we have used in part 2. Already I have drawn this diagram there and I have explained you. Now here we can see here, experience is an independent variable which is impacting sales. Education is also an independent variable which is impacting sales, right? You can see the arrow mark. This arrow mark which is indicating head is towards sales and tail is towards an independent variable. We have we have a covariance where this covariance is having two heads. So this is called as a covariance symbol. These are impact symbol. Now we are saying experience and education is impacting sales, but we don't have error on this. When you see the equation y is equal to a plus b1 x1 plus b2 x2 plus error we said. So always dependent variable should have an error on it. For drawing error, what you must do is you must select this button which is called as add a unique variable to an existing variable. Click, select it, drop it on sales. Now this is error term. So this is what you must do. Always a dependent variable should have an error. What is a dependent variable? Whenever you have a single headed arrow pointing, okay, this becomes a dependent variable. In Amos, always you must remember, in further cases, again I don't say the same point, dependent variable should have an error. Dependent means when you have a single headed arrow pointing towards it, it is called dependent. It is called as endogenous variable. Endogenous variable, exogenous variable. When the arrow is pointing towards this, this becomes endogenous and this becomes exogenous variables. Experience and education are exogenous variables and sales is endogenous variable. So this endogenous variable should have an error on it. Error term means this is a symbol which shows an error term. This error should be there. Simple thumb rule is whenever there is a single head arrow pointing, it is called as a dependent and it should have an error term on it. Now we must name it. So we'll give a name to it, double click on it and write the variable name as E1. This is error. Okay, so you can see it is E1. I have entered the variable name as E1. Generally E value, that word E alphabet is used to symbol for errors. So we'll keep it as a E1. Now save the file. Save the file. Already in the earlier video I have shown how to add the file. I have added the file. You can see here. Here we have added sales file. You can see sales.sav. Okay, click OK. Now if you see the variable names also, you'll see the same variables, experience, education and sales. The same file which I showed in SPSS I have added here. Now let me do the analysis. For doing the analysis, you need to click this button which is called as calculate estimate. Okay, this is a button which is called calculate estimate. When I click calculate estimate, we'll have to observe one important thing. On the top you can see this is called view the input path diagram. This is output path diagram. Now you can see this output path diagram is inactive. It is not colored, right? Now once I click this calculate estimate, this becomes activated. Now I'll just show you. If I click this button, now analysis has happened, now it became activated. Once I click this view the output path diagram, now we got the values on this. We got the values on this, right? And these values are unstandardized values. Unstandardized values. First we will discuss unstandardized values and we will discuss the standardized values later. Now you can see the unstandardized values. Experience is having how much impact it is having? 1874.5. This is the same value which we got in SPSS also. In SPSS also we got the same value. We said experience, when experience increased by 1 unit, sales will increase by 1874.5 units. This value which you are seeing on arrow, this is called as unstandardized estimation value. Now coming to education. For education, how much impact education is having on sales? It is 609.39. This is also unstandardized estimation. Means if education increased by 1 unit, sales will increase by 609.39 units. So let us see now whether it is significant or not. To know the output, to see the output values, you must click this button which is called as view text. View text button. When you click this view text button, we'll come to the Amos output. In Amos output, first we will see the estimation values. These are the estimation values. Here you can see regression weights. These are unstandardized weights. Unstandardized weights. So what is the impact of education on sales? You can see it as 609.391. What is the p-value? P-value is 3 star marks. Star mark means 0.000. Star mark means 0.000. We already discussed, if significant value is less than 0.05, then education is having significant impact on sales. In null hypothesis wise, you want to say, again make the statement, education has no significant impact on sales, and write this statement. If p-value is less than 0.05, reject the null hypothesis. Reject the null hypothesis. Now what is the p-value? 0.000. We said if it is less than 0.05, it is less than, it is impacting significantly, means we are rejecting the null hypothesis, and we conclude that education is having significant impact on sales. Coming to experience also, experience is also having significant impact on sales, and these values are same as the values which you have seen in Amos SPSS values. You can see the same values here, 1874.5. here you can see 1874.5 value, and here you can see education 609.391. Here you can see 609.391, and both are significant. Here also 0.000, 0.000. Both values are significant. We don't need to bother about these values at the moment. SC means standard error. CR means critical ratios. We don't need to bother about these values at the moment. Only check these values where the estimations are same. Estimations are same in both cases, right? Now see the covariance also. The covariance between education and experience is 1.209. Is it significant? No, it is not significant, because p-value is how much? 0.097, which is more than 0.05. So there is no significant covariance between education and experience. Education and experience have no significant covariances. Now let us see how to get the standardized values, because we don't have standardized values in this table. So let us close this one. To get the standardized values, we need to do some settings. We need to go to this value which is called as analysis properties. But to get this analysis properties table, you need to first come to input path diagram. Now we are in the output path diagram with the values, right? So let me click this button called view the input path diagram. Now once I click this view input path diagram, now I need to go to analysis properties. In this analysis properties, we must click this output. In this output, we must select standardized estimations. Standardized estimations. And we must click this button also, which is called squared multiple correlation. Squared multiple correlation is nothing but R square value which we have seen in SPSS software. R square value. So now when we select the squared multiple correlation, we get R square value also. And when we select this button standardized estimations, we will get standardized values also. Now we don't have here anything called as OK button. Directly you need to close the window. Now save it once again and again calculate estimate. Now after calculating estimation, to see the values, you need to select this view the output path diagram. These are the values. Now you can see these are unstandardized values. Now when you want to see standardized values, click this button. This is standard. Now experience is 0.92. Education is having impact of 0.24. Okay. And this value is called as squared multiple correlation, which is nothing but R square value. Let us see the view text. Let us see the table value. In this estimations, now you can see here this regression weights are unstandardized value. Already we discussed this table. Now we will discuss about standardized regressions. Education on sales 0.244. Experience on sales 0.919. Let us see what is the value we got in SPSS. Here experience is 0.919, education is 0.244. So yes, you can see education is 0.244. Here you can see education is 0.244 and experience is 0.919. 0.919. So both values are matching. So standardized values are both same in SPSS software as well as SPSS Amos also. Why I am showing compared to SPSS means generally we are familiar with SPSS, right? So when I show in Amos, you will get that familiarity. Okay, same type of values you are getting. For that purpose only I am showing in SPSS Amos. So we have seen unstandardized values and standardized values. Standardized value of covariance is called as correlation. So the correlation between education and experience is 0.161. 0.161 is a correlation between education and experience. Already we said it is not significant. It is not significant. So we don't have a significant correlation between education and experience. So here we have discussed about unstandardized values and standardized values also we have discussed. Let us see this value which is called as squared multiple correlation. Squared multiple correlation. What is squared multiple correlation? 0.976. 0.976. This value we got in R square value. You can see the R square value. 0.976. Exactly we got the R square value. This is the variance explained by the independent variables on the dependent variables. Now coming to the diagram once again. Now this is unstandardized values I said, and let us see unstandardized values. Okay, these are unstandardized values. Now what are these values? These values are mean and variance. Each variable will have mean and variance. So this 9 and 19 is a mean and variance. We will discuss about these values further in the other examples. Now I'll show you a way to find this intercept in SPSS Amos. Here we need to do a setting to get intercept value in Amos. For that you need to click this analysis properties. In analysis properties, in estimation tab, in this tab we need to select this check button that is estimate, means and intercept. If you select this button only, you will get that intercept value. After selecting this check button in estimation tab, close this and calculate estimate. Once you calculate estimate, we can go to view the output path diagram. Now here you can see the estimation value, intercept value. The intercept value is minus at 10,385.34. In view text also, we can see that value. In estimations, we'll have here in intercept. In intercept, the value is minus 10,385.38. Now let us see how we are going to copy this diagram to Word diagram. Okay, exporting the values to Word diagram. To export this value, what you must do is you must click this button which is called as export, copy the path diagram. Just click this diagram, this button, copy the path. After selecting it, close this window. On the desktop, we'll open a Word document. In this Word document, let me write it as SCM and Control V. When I press Control V, it is pasted. The diagram is pasted in this form. We don't have a direct exporting. We need to copy it from the SPSS Amos and we must paste here. Now how to paste the tables? You need to come to table view. In the table view, here you have an icon, small icon, copy to clipboard. When I click this button, copy to clipboard, we'll get all these values copied. In the Word document, you must simply press Ctrl V. So all the values are copied here. So this is how we copy the path diagram and the view diagram to Word document. Now let me copy all these values to ChatGPT and let us see how ChatGPT will interpret these results. For copying all these values, what we must do is we need to click on the values sheet and select this estimations. Once it is highlighted, click this button which is called as copy to clipboard. After copying, we'll go to ChatGPT. Here in ChatGPT, I have pasted here. You can see all the values are pasted here. After pasting, ChatGPT has given these interpretations. The interpretation for regression weight is education. The estimation weight is 609.391 with a standard error of, so it has explained beautifully all the interpretation values. Even standard regression weights also it has explained here about the sales, how much education is impacting sales, how much is experience impacting the sales. Even mean values also it has explained. Intercept value, covariance, correlation, even variance also it has explained. At the last, even squared multiple correlation also it has explained. And I have asked write a summary of the above results in a simple and easy way to understand. See, it has written in an easy way. In regression it has written for education. For each unit increase in education, sales is expected to increase by around 609 units. This relationship is highly significant. For experience, for each unit increase in experience, sales is expected to increase by around 1874 units. This relationship is also highly significant. See, all it has written in a very simple and easy way. Now what I did is I have copied the same results in BARD also. When I copied all the values in BARD, it has shown this interpretation. Okay. Now here the interesting part is how to interpret the intercept it has shown. The intercept, which is a value of sales when education and experience are both 0. Means when experience is 0, education is 0, the sales is minus at 10,385 units. It means if employee don't have experience, if the employee don't have experience, it is a loss to the company. How much loss it is going to show is 10,385 units. So the employee must have minimum education and minimum experience must be there. So it has clearly explained about all the values. Even you can see the squared multiple correlation, which is a measure of how well the model fits the data, is 0.976. This means that the model explains 97.6% of the variance in sales. So you can use this artificial intelligence applications and create valid interpretation. So it has written summary also. For every additional year of education, sales is expected to sell 609 units more. And I've asked her, write a summary of the above results in a simple and easy way to understand. It has given a very simple way to understand the interpretation part, and it has even thrown a table for us. It has given a table for us also. So this is all about the interpretation of regression analysis in SPSS Amos. So in this video we have discussed about how to do the basic analysis in SPSS Amos with the two independent variables. We have taken one example and discussed what is unstandardized values, what are standardized values, what is R-square value, and how to see the p-value, that is significant value. These things we discussed in this part 3 video. Thank you.